Okay, here's number 52. We're supposed to check all statements that are true. So angle A and angle B are complementary. This one's actually pretty easy. We're given that C is a right angle, so we know that's 90 degrees. We know a triangle has a sum of 180 total. So if C is already 90, then A and B have to add to make 90. So that's clearly true. And I'm going to just write a quick statement above this that the measure of angle A plus the measure of angle B equals 90, because that's what it really means, that they are complementary. We're going to use that fact later to answer one of the other questions. And one of those other questions is happening right now. It says the measure of angle A equals 90 minus the measure of angle B. If I just take the equation I just wrote, if I take that little equation and subtract B from both sides, then that's exactly what I would get. I would get the measure of angle A is equal 90 minus the measure of angle B. The next one is tangent A equals sine A over cosine of A. This is one of the harder questions in the packet. To figure this out, we can rewrite the tangent of A separately. So the tangent of A can be written as BC, because that's opposite, over adjacent, AC. The right side of the equation is sine A divided by cosine of A. So the sine of A, I'm going to put in red, and the sine of A would be BC divided by AB. That's the sine of A. And that's on top of my fraction. Cosine of A is on bottom. I'm going to write that in black. So the cosine of A would be AC, because that's adjacent, and then AB, because that's the hypotenuse. So I have the sine of A divided by the cosine of B. This whole part of the expression is a mess that needs to be simplified. To simplify that, it's a fraction divided by a fraction. So instead of dividing by AC over AB, I can multiply by the reciprocal. So I'm going to take this side of the equation, I'm going to rewrite it as BC over AB times AB over AC. Again, this is called multiplying by the reciprocal. And what happens is the AB's cancel, and you're left over with BC on top, AC on bottom, and that's exactly what I had originally on the left side of my equation, BC over AC. So this is a true statement then. BC over AC, that's tangent of A, is equal to BC over AC, that was sine of A divided by cosine of A. Alright, the next one is just an expression of the Pythagorean theorem. AB is the hypotenuse, that's like the C part. AC is like the A part. And then BC can be known as the B part. So it's just A squared plus B squared equals C squared. So that is true, that applies. Next up, sine of A equals the cosine of B. Let me clear some space. I'm just going to write out the expression for each of those and see if they're equal. So the sine of A here's A, I need opposite, BC is opposite, over hypotenuse, AB. Let me write out the cosine of B. So here's B. Cosine is adjacent over hypotenuse. BC is adjacent. AB is the hypotenuse. And I can see those two expressions are the same. So that is true. I'll check that. Next up, cosine A equals sine of 90 minus A. Well, this 90 minus A part is the weird part of this problem. But 90 minus A is the same as angle B, because way back up here in the first question, if I just change that expression around and I subtracted A from both sides, I would end up with this equation. The measure of angle B is equal to 90 minus the measure of angle A. So 90 minus A is angle B. This is really just B. So I could change this question around. It's really saying cosine of A equals sine of B. So just like before, I'm going to write out each of those expressions. The cosine of A is, let's see, here's A. Cosine would be adjacent, AC, over hypotenuse, AB. The sine of B, here's angle B. Sine is opposite over hypotenuse. Opposite from B is AC. The hypotenuse is AB. And I can see that these two expressions are equal. So I'm going to check that. And the last one if angle A is congruent to angle B, then sine A equals sine B. This is one of those that I would say is so easy that it's actually hard. If A and B are the same angle, then if you take the sine of A and the sine of B, you're taking the sine of the same angle. For example, if A is congruent to B, maybe they're both 42 degrees. So if I do the sine of 42, is that the same as the sine of 42? And this should be a very obvious yes. And of course 42 is just a number I made up, but I could have made up any number, and this would always be a true expression. So maybe these angles were both 36 degrees. So A is congruent to B, A is 36, B is 36. If I do the sine of 36, does that equal the sine of 36? And the answer should be yes, the sine of 36 is the same as the sine of 36. Okay, question 53. We're looking at these two triangles. Sandra thinks that since the triangles are congruent, and by the way, the triangles are congruent by side, side, side. That's why she thinks that, and she's right, they are congruent. She thinks that the sine of A should equal the sine of B. The problem is that she's wrong. And the reason is because the sine of A in this triangle is 12 over 20. The sine of B in the right triangle is 12, B, whoops, here's B. So opposite is 16, and then the hypotenuse is 20. So 12 twentieths, which could reduce, divide by 4, this would be 3/5. 12 twentieths is not the same as 16 twentieths. 16 twentieths is 4/5. So those are not equal expressions, and that's why Sandra is wrong. Okay, in this problem, 54a, show that the value of the cosine of S is the same if triangle SQU is used, that's the big triangle, or if triangle SRT is used, that's the small triangle. So we can see that S in this triangle is the same as S in the big triangle, so it's the same angle. So the question is saying, is the cosine going to be the same in the red triangle, in the red little triangle, as it is in the big blue triangle? So the cosine of S in the red triangle would be adjacent 10 over hypotenuse. Adjacent is 8 over the hypotenuse, which is 10. That reduces to 4/5. If I move to the big blue triangle, so the red is for the small triangle. If I move to the big blue triangle and I do the cosine of S, so in this big blue triangle, cosine S, adjacent is 20 because QS is 20. 12 plus 8. And now the hypotenuse is 15 and 10 combined. 15 plus 10 is 25. So the cosine of S is 20 over 25. That reduces to 4/5. So it's the same in the little red triangle. It's the same in the big blue triangle. So all the work that I have here is good enough to answer letter A. Letter B, what is the value of sine of U? Well, here's U down here. Sine is opposite over hypotenuse. The opposite side is 20. And again, I'm just looking at the big blue triangle right now. Don't look at this 6 piece. This 6 piece is really not used for the current question. So sine is opposite over hypotenuse. 20 is opposite. The hypotenuse of this big blue triangle is 25. 10 plus 15. We should always reduce fractions if possible. This is 4/5. And that will be it for letter B. Letter C, is the cosine of U equal to the cosine of T, Y, or Y not? So the cosine of U, I need to use the big triangle for that. So the cosine of U in the big blue triangle is 15 over 25. That reduces, if I divide by 5, that will be 3/5. So that's the cosine of U. Now I can look at the cosine of T. And for the cosine of T, I'm looking at the little triangle. So now I'm back to the little red triangle. So I need the cosine of T. Here's T. Adjacent would be 6. Hypotenuse would be 10. 6/10 reduces, I can divide by 2, and that is 3/5. And I think this is enough to show that, yes, they're the same. The cosine of u is the same as the cosine of t. And I can expand on this problem by saying that angle u is actually congruent to angle t. They would have the same degree measurement anyways, which is why they have the same cosine as well. Okay, problem 55, our first word problem. The nice thing about this word problem is that it already has a diagram for you. On the exam, there'll be some questions where you have to make your own diagram. And even on the exam review, we'll get into some questions where you have to draw your own diagram. So a skateboarder has a piece of plywood that she wants to use as a ramp. The plywood is 16 feet long, so here is the ramp. I'm going to do, the ramp is this red part. It's 16 feet. She wants to put a vertical support under the ramp. That's here. So that the ramp is at a 20-degree angle with the ground. 20 degrees is already there for us, so that's nice. This view is from the side of the ramp. So how high is the vertical support? I can just call this x. And it doesn't say so, but I'm supposed to assume this is a right angle. Because when it says that something is vertical, that means it's going straight up and down from the ground. So the fact that it's straight up and down would make this a right angle. So I can use right triangle trigonometry. 20 is the angle I can use. X is the opposite side. 16 is the hypotenuse of this triangle. If it's opposite and hypotenuse, that must be a sine problem. So the sine of 20 equals opposite over hypotenuse. I need to multiply by 16. 16 cancels on the right, bring down x. And on my calculator, I'm doing 16 times the sine of 20. So 16 times the sine of 20. I end up with 5.47. And the question says round to the nearest hundredth. So I did round to the nearest hundredth. So this is 5.47 feet. Make sure you put your units in to get full credit. Okay, 56. Now we have to make our own diagram. Josh has a 17-foot ladder. He would like to place his ladder against the side of a vertical wall. So the top of the ladder is 15 feet up the wall. So in all of these ladder problems, I can just tell you that they're going to look like this. We're going to have a wall, and the wall is going to be vertical, straight up and down. The ladder is always going to be the leaning part, or it ends up being the hypotenuse. And then, of course, you have the ground on the bottom, which is horizontal. So Josh has a 17-foot ladder. Here is 17. It reaches 15 feet up the wall. And the last sentence here says that safety guidelines state that the angle that the ladder makes with the horizontal can be no more than 70 degrees. I'm not going to use that until letter B. To answer letter A, I really don't need this information yet. So letter A, can Josh safely place the ladder against the wall? I have to find this angle right here. And you've seen us use the variable theta before for a missing angle, so I'm going to use theta here. This would be a sine problem because 15 is opposite and 17 is the hypotenuse. So it's the sine of theta equals 15 over 17. And this is the case where you want to use inverse sine. So you would do the inverse sine on the left of the equation. You would take the inverse sine on the right of the equation. These cancel, bring down theta. And now on the calculator, you need to work out sine inverse of 15 over 17. So you would press the second button, second sine, and then 15 divided by 17. We get 61.9 degrees. So 61.9 is this angle that the ladder is with the ground. The question is, can Josh safely put the ladder against the wall? Yes, because now we need this piece of information actually. So now the ladder cannot be more than 70 degrees. 61.9 is okay then, because that's less than 70. So yes, he is safe since 61.9 is less than 70. Okay, letter B. Using the safety guidelines, what is the highest distance that the top of the 17-foot ladder can be above the ground? And we're going to round to the nearest hundredth. So going back to my diagram, this theta is 61.9 right now, but it could be larger. The ladder right now is at a 61.9 degree angle. I could increase that angle and make it larger, and then it would increase the height that the ladder reaches up the building. So the highest angle I can use is 70. So I'm going to do a new diagram, and now I'm going to take a 70 degree angle with the ladder. The ladder is still 17 feet, but I don't know how high it's going to reach. So I'm going to find x in this red triangle down here. It's another sine question. So sine of 70, x is opposite, 17 is the hypotenuse. I will multiply by 17 so that the 17 cancels. And now I'm doing 17 times the sine of 70 on the calculator. $15.97. It said round to the nearest hundredths. This is perfect, 15.97, and my units are in feet. So I'm going to put FT in there for feet. And that is it. That's the highest that the ladder could reach if we use the maximum angle of 70 degrees. 57. An airplane takes off from a runway and climbs at an angle of 15 degrees. So the runway is here. The airplane takes off from the runway at 15 degrees. So this little angle here is 15 degrees. That's how much the airplane's like going upward. So it's going up 15 degrees. And after the plane has traveled 1 mile, 5,280 feet, that would be here, it's asking me how far the plane has traveled horizontally. Well, the horizontal distance is down here. The horizontal is like the ground. This is the horizontal. So it makes a little right triangle. I need to find x, the horizontal distance. This ends up being a cosine problem. Cosine of 15 is equal to adjacent, x, over hypotenuse, 5,280. And I need to multiply by 5,280 to finish this out. I want to multiply by whatever's on the bottom. So I'm going back to the calculator, and I'm just going to have to input this, 5,280 times the cosine of 15. 5,280 times the cosine of 15. So 5100.088. To make sure I round correctly, let's see, it says round to the nearest foot. The nearest foot really means the nearest whole number. So the nearest whole number is just 5,100 feet. So that's this horizontal distance that the airplane has traveled. After the plane has traveled 1 mile, how far has the plane traveled vertically? We can use the same diagram as above. I just need to find the vertical distance now. So I can do a sine problem. Sine 15 equals x, that's the opposite, over hypotenuse 5280. And essentially it's the same as what we did before. It's just now a sine problem instead of a cosine problem. So I'm going back to the calculator one last time. 5,280 times the sine of 15. So 1366.56. Round to the nearest foot again. If I'm rounding this to the nearest foot, it would be 1367 because the 5 tells me to round up. So 1367. 1367, that's my x, and that's in feet. So that's this vertical distance. Okay, a farmer wishes to make separate sections of a piece of land, as shown in the figure. So the diagram's already there for us. All the triangles are right triangles. What's the value of x? Well, this is just a Pythagorean theorem question. So I can just do a squared plus b squared equals c squared. Remember, the c is the hypotenuse. In this case, the c is like the x. So I'm going to use x instead of c. I work it out. 15 squared is 225. 20 squared is 400. Add those together to get 625. And I would take the square root of both sides. So square root, and this works out perfectly because the square root of 625 is 25. That's the answer for x. So we can put 25 meters for x. Now we have to find y. This is yet another Pythagorean theorem question. I can do a squared plus b squared equals c squared. Now 65 is the hypotenuse. Because it said assume that every triangle is a right triangle, that means that this must be a right angle. So c is the hypotenuse, so that's 65. So I'm doing y squared, that's essentially a squared, plus b squared, 25, equals c squared, and the c is 65. So I have some big numbers, probably need the calculator to help me. Y squared plus 625 equals 65 squared. 65 squared is 4225. I need to subtract 625 from both sides. So I could just go back and do minus 625, the answer minus 625. That's 3600. And that seems like a nice number. I think this is going to work out well for us. I would finish by doing the square root to get rid of the square. And let's see, the square root of 3600 is perfect. It's just 60. So that is y. I'm still working in meters, so 60 meters. Okay, question 59. And this is the last question in the exam review. A swimmer tries to swim straight across the stream. So the swimmer's intended path is here. They're trying to swim straight across the stream. The stream is 100 feet wide. A current in the stream is perpendicular to his intended path. Here's the current. And it causes him to land 20 feet downstream from his intended landing point. So essentially, this is just a right triangle problem. This is going to be a right angle. We know that because it said it was perpendicular to his intended path. And if I want to find the actual path, which is what they're asking down here, I can just do a Pythagorean theorem type of setup. So we can do 20 squared plus 100 squared equals, I'll just call this c, equals c squared. C is the hypotenuse. Always pay close attention to that. 20 squared is 400. 100 squared would be a 1 with 4 zeros after it. So that's the same as 10,000. 400 plus 10,000 is 10,400. And now I need to do the square root of that, just like I've done on the previous couple of questions. So the square root of 10,400 is 101.98. So we could round that to, I guess, 102 if we wanted to. It says to the nearest tenth, so this would be 102.0. And that's in feet. By the way, when it says nearest tenths, that was kind of a tricky one to round if you're not very good at rounding. So the tenths place is where this 9 is. The 9 becomes a 10. I have to round this 9 up because 8, of course, is 5 or larger. So the 8 makes the 9 round to 10. That means that this 1 goes to a 2, and 9 becomes 0 basically. So you put a 0 in the tenths place, and then the 1 becomes a 2. So 102.0. And even though there's a 0 there, sometimes you'll ask, do I have to put the 0? Well, yes, if it says round to the nearest tenth, you do have to have something in the tenths place. Even if it's a 0, you still have to have something in that tenths place. So that 0 is needed there. Okay, and finally, at what angle theta was his actual path to the intended path? Give your answer to the nearest tenth of a degree. So I'm just finding theta. This is going to be a tangent problem. And it's tangent because 20 is opposite and 100 is adjacent. Tangent is opposite over adjacent. So tangent theta equals 20 over 100. I need to do tangent inverse. Anytime I'm finding an angle with trig, that's when I use an inverse function. So second tangent 20 over 100. Second tangent 20 over 100. It said round to the nearest tenth. That would just be 11.3. 3 stays the same since there's a 0 to the right of 3. So this is 11.3 degrees. And at this point, we are finished with the exam review. Good luck. I hope you enjoyed the video.